I never actually imagined that I would make it to NASA. I knew about NASA and I thought everything that NASA did was really interesting, but I never actually imagined myself to make it to work in a place like this. My name is Sam Zauber. I'm a test engineer here at the 14 by 22 foot subsonic wind tunnel at NASA Langley Research Center.
My name is Frank Quinto. I am the facility manager. I have been working at NASA Langley for over 42 years. The coolest part of my job is that I get to see things that are going to happen in the future, like the space launch system before we got to launch. The airplanes that we test will probably be flying in the future, years from now. And the other cool part is I get to work with wonderful people like Sam here. Don't do that. Now I'm going to be laughing all the way through every question.
Testing in this tunnel is really important. Every time you fly commercially, you fly on a plane that was tested at a facility such as ours. We've checked it for safety, we've checked it for fuel efficiency, and we've helped improve the features on it that leads the technology into the next generation of aircraft. As a test engineer for the wind tunnel, I do the technical coordination for a wind tunnel test. So if a researcher wants to test an airplane in our tunnel, then I set up the instrumentation and the data system so that we can get them the best possible data. A wind tunnel works by blowing air over a model that we are interested in learning more about.
Our maximum speed in here is about 235 miles an hour. With that speed, we normally concentrate on what we consider the most important part of flight, which is the takeoff and landing. There are a lot of things that we tested that need to take off and land. Future airliners, the space launch system, helicopters, military airplanes. So those are some of the things that we have tested in our facility.
So as you can see behind me, we have a very large fan.
The fan is 40 feet in diameter, consisting of 9 wooden blades made out of Sitka spruce. Each fan blade is 16 feet long, weighing about 650 pounds apiece. The fan is attached to a 12,000 horsepower electric motor.
That fan will push air through a tunnel that's looped on itself. And on the other side of this tunnel will be an aircraft or whatever our model is.
Well, some of the strangest things that we have tested in a 14 by 22 include things like wheelchairs, exhaust stacks, radar dishes, wind turbines, race cars, NASCARs, Formula One, and Indy racers.
Just like any other engineer, one of the big tasks that always comes up is troubleshooting. Things don't always go the way that you expect them to go. Every day there's some other problem that needs to be solved, whether it's a big problem or it's a small problem, and it always keeps you on your toes every day.
You make it work, Sam.
I make it work. We do a lot of visualization in our tunnel, which includes putting smoke through the tunnel. Sometimes we'll put fluorescent oil over the surface of the model. And in these different ways, we're able to actually physically see how the wind is moving across different areas of our model. And I find that really interesting because I'm a visual learner. When I was in high school, my favorite STEM subject actually was chemistry. Thank you, Mrs. Maurer. She did a lot of labs that were hands-on. I think oftentimes people don't think of how important just tinkering with electronics or with technology really can be beneficial.
Oh yeah, I did a lot of tinkering as a kid. I built a lot of model airplanes, which was nice because then I got to figure out what the different parts of the airplanes were and how they go together.
A lot of people think that just because they are more artistic or more creative that they're not cut out for a STEM field. But in all honesty, engineers, scientists have to be creative and have to be somewhat artistic to be able to come up with these new ideas and see how they can solve the problems in the world around them. You don't have to be the biggest genius in math to be able to be an engineer. If you understand the concepts and if you understand how they apply to the world, then that's how you become a successful engineer.
Almost everything in the world today is part of science, technology, engineering, or math. Just keep at it. If it's not interesting to you, give a different perspective for someone else.